Hello, my name is Zhang Meinan. I'm a master's degree student at China University of Petroleum, East China, located in Shandong, China. The title of the paper I will present today is Stability Analysis of Prestressed Cable Supported Tank Shell Roof. In this era of gradually increasing energy demand and reserves, tanks are development towards large scales, and tank roofs must also continuously expand their spans. However, it must be said that large span tank shell roof structures face huge challenges in terms of stability. However, the, the engines of prestressed steel structures may solve this problem. As shown in the figure, prestressed cables can restrain the outwards displacement of the reticulated shell through radial results force, reduce the throat of the ring beam, thereby optimizing the internal force transmission mode of the structure and improving the ultimate bearing capacity of the structure. But how it will perform specifically when combined with the storage tank reticulated shell roof structure remains to be verified. This paper combines pre-stressed cables with lattice shell structures and applies them to tank roofs and conducts static and stability analysis on them, so as to provide new ideas for the structural design of large span lattice shell tank roofs. The above as overall mode of the tank and the lattice shell modes under different prestressed cable layout methods, including circumferential cable layout, spaced cable layout, and radial cable layout. First, by comparing and analyzing each mode under different cable layout methods with the model without prestressed cables, it can be concluded that different prestressed cables improve the lattice shell structure to varying degrees. Among them, the spaced cable layout method has the most significant improvement on the structural distance displacement and ultimate bearing capacity. Then, taking the spaced cable layout as an example, by changing the magnitude of the applied stress value and analyzing of the response changes of the structure, it can be known that as the pre-stress increases, the design displacement of the lattice shell structure, the internal force of the members, and the ultimate bearing capacity all increase accordingly. But the effect is not significant. Finally, the research results proves that the addition of prestressed cables can indeed improve the stability performance of tank shell roofs. This provides certain reference value for the future structural design of tank shell roofs. However, this paper only analyzes the prestressed cable layout max and magnitudes. Subsequent work can be future carried out from aspects such as structural stability under dynamic loads and earthquake action, or optimizing the connection details between prestressed cables and reticulated shell structure joints. Thank you all for listening. Wish you a wonderful day.